All right, here's another proof. So we're given that triangle ABC is isosceles, right? Which means two sides are the same. They have two congruent sides. And so the two sides that are congruent are AB and CB. Okay, and then M is the midpoint of AC. So I'm going to write down the givens. So triangle, or actually I'm just going to put segment AB is congruent to segment CB. So we don't necessarily have to put isosceles on there. But let's mark this. So segment AB is congruent to segment BC or CB. Okay, then we know that, and that's given. And then we're also given that M is the midpoint of AC, right? So that's also given. So we know that these are congruent, so that's enough there. But with the midpoint, we can say, well, that means that AM is congruent to MC. So segment AM is congruent to segment MC, and that's because of the definition of midpoint. All right. So now the last thing we need is we need either this angle to be congruent with this angle, which I don't see any supporting evidence for that, or we could say that this side is congruent with itself, right? Which we know we can do. And so I can say that BM is congruent with MB. I'll just switch it up this time. And I can say that by the reflexive property, right? Because they're the same line. All right, so it seems obvious, but we have to include it. So now we have side, 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 congruent with side, side, side. And so that means that those two triangles are congruent, right? So triangle ABM is congruent with triangle CBM by side, side, side theorem, or postulate, excuse me. All right, just to double check, A corresponds with C, that is the case. B corresponds with B, that's the case there. And then M corresponds with M, right? That makes sense.